Now we come to the 4.2.2, the linear equations. So linear equation is a first order differential equations which you can find the equation in this form, where you can see you have a first order derivative together with one variable y inside an equation. Okay, once you have identified a linear equation, the next thing that you have to do is you have to find the integrating factor. Okay, so you can find the integrating factor by using this formula. Once you have identified the integrating factor, then you can solve this linear equation by using this formula. Okay, let's just look at this example. So in this example, you have the dy dx with one variable y. And let's just compare with the general form of the linear equations. So this is the general form of the linear equations. If you look at the equations, the left-hand side of the equations, you have the dy dx together with the variable y. So instead, you have to rearrange these equations just that it looks like the general form. Just move this one to the left-hand side, so you will have this one. So let's just compare this one with our general form. So now you can identify your px and px and qx. So your px is the one that is next to the variable y. So this is your variable y. What is your px? Your px is negative 3x squared. So your qx is the one at the right hand side of the equation. So your qx is 2x squared. Now we're going to identify the integrating factor. So integrating factor, you can identify it by using the formula of the if equal to the exponent integration px dx. Now px here is negative 3x squared. So substitute it. And then let's just integrate on the power only. So if you integrate, so you will have negative 3x cubed over 3, and simplify it, you have negative x cubed. So your integrating factor that is equal to the exponent to the power of negative x cubed. So let's just solve this differential equation by using the formula. So this is a formula, yif equal to the integration qif dx. So y multiplied with the if. So what is your if? Your if is e to the power of negative x cubed. So this is the one, and equal to the integration, and qx. Your qx is 2x squared. And multiply with the if dx. So if is the exponent. So this is exponent with the dx. Okay, so focus on the right hand side. So if you focus on the right hand side, you're going to use the technique of substitution to do the integration. So substitute this one as a u. Okay, so differentiate this one. So if we differentiate, so you have du equal to minus 3x squared dx. So observe what we have here. You have x squared dx, and you have x squared dx here. So means that I can move the negative 3 to the left hand side. So I will have negative du over 3 equals to the right hand side, it will have x squared dx only. So rewrite this one just that you can do the substitution easy later. So let's just rewrite it. So factor out number 2, and then write the exponent first. Write the integration with the exponent. Okay, and then group the x squared with the dx. Okay, now let's just do the substitution. Okay, so this e to the power of negative x cubed. So this one, you can substitute the negative x cubed with the u. So you have eu. And x squared dx is actually, you can substitute this one with negative du over 3. So then we have here. Okay, simplify this one. And then integrate e to the power of u. And then you have the result of e to the power of u. And don't forget to write the plus c. Okay, don't leave your answer in terms of e to the power of u. Okay, so substitute the u back. Okay, so what is your u? Your u is actually negative x cubed. So substitute back, so you have this one. And don't leave your answer in terms of this way, okay, because your left hand side is supposed to be only have the y only. So just divide all of them with this exponent to the power of negative x cubed. So you divide all of them with this one, so you have the next line. Okay, and then go to do the simplification. So let's just simplify it. So for this one, okay, you can cancel this one and this one. So you will have negative 2 over 3 only. And then for this one, so what happened to this? So this one, you have the c divided by the exponent. So you have c divided by the exponent minus x cubed. So because it's divided, you can write it as minus x cubed. Okay, so the minus will give you a positive. Okay, so you have a positive x cubed here. So then you will have here plus c e to the power of x power of 3. Okay, so this is the general solution for this differential equation. So example 2 is an initial value problem because you have initial condition y1 equal to 2. So let's just look at the differential equations that we have here. You have dy dx and you have one variable y. Let's just compare with the general form of the linear equations. If you look at the general form of the linear equations, what happened is in front of the dy dx, you have nothing. Okay, but in our differential equation, in this example, you can see that we have x squared. So it means that you have to modify this one just that it look like the general form. So try to modify this one by divide all of them with the x squared. So divide all of the terms that you see here with the x squared and let's just simplify it. So if you simplify this one, so you can cancel this and this, then we only have dy dx. And for here, you cancel this one and this one, so you have 2 over x and you have the y. And then for the right hand side, you will have 1 over x squared. So this is a form that is look like the general form of the linear equations. So now we're going to identify what is our px and what is our qx. So for our px is the one that is next to the variable y. So this is your variable y. So the one that is next to variable y is 2 over x. So means that your px is 2 over x. And what is our qx? Our qx is the one that is at the right hand side of the equation. So this one is your qx. Your qx is 1 over x squared. The next thing that we're supposed to find the integrating factors. But before we look at the integrating factors, let's just look at some basic mathematics. So if you look at it here, we have the e to the power of ln x. Okay, what happened here is this one is basically, it can be equals to the x. Okay, it means that basically you can cancel the e and the ln together. So you have the answer that is x. Okay, same thing happened for this one. You have e to the power of 5 ln x. You can bring the 5 to here, so you have the ln x power of 5, and then you can have the answer that is x power 5, where you can cancel the e and the ln together. So this is the answer. Okay, let's just look at the example. So in here you have the e ln cos x, where the answer is actually just cos x because you can cancel this one and this one. This is actually cos x. So let's just look at the last example. Okay, so in here you have e to the power of e to the power of 2 ln cos x. Okay, so means that you can bring this one to here. So I will have this one, and then it is actually equal to this bracket square. So you can cancel the e and ln. So you have bracket square, and this one you can simplify. If you simplify, then you will have the cos square x. So that is the basic mathematics that you're supposed to know. Okay, let's just go back to these integrating factors. So let's look at the general formula that we have in the integrating factors. That is if equal to e to the power of px dx. So your px here is actually 2 over x. So let's just substitute here. Okay, you actually can factor out number 2 from this 2 over x. Okay, so you factor out number 2, so you have integration 1 over x dx. Okay, so now, okay, 1 over x, if you integrate it, it basically give you ln x. Okay, and then it means that you're going to use the basic that we have learned just now. So this is basically, okay, you can bring this to the back, so you will have the next line. So you have ln x power of 2. Okay, and then it means that this is actually equal to your x squared because you can cancel this 2, so this is actually equal to x squared. Now, once you have identified the integrating factors, the next thing that you need to do is you need to solve this differential equation by using the formula. So this is the formula, and our formula says that, okay, you're supposed to have y multiplied with if equal to integration qx if dx. Okay, so y multiplied with if, what is your if? Your if is x squared. So then we have the next one. So we have y multiplied with x squared. equal to the integration qx. Your qx is 1 over x squared, so 1 over x squared, and multiply with the if dx. So your if is the x squared here. So then we have the next one. So this is the one, x squared dx. Okay, then let's just simplify this one. So if you simplify it, basically you can cancel the x squared with 1 over x squared. You cancel, okay. If you cancel, right, you cancel this one and this one, you only have 1, okay. So you integrate the 1, so you will give you x plus c. Do not leave your answer in this way because your left hand side is supposed to be y only. So you divide all of them with the x squared. So this is what we have. And simplify it. So you will have y equal to 1 over x plus c over x squared. And this is actually the general solution for this example. But because we have the initial conditions, you have to continue. So let's just see what happens when y1 equal to 2. Okay. So this is your initial condition. This means that your x is actually 1, your y is actually 2. So let's just substitute into the general solution. So let's just substitute here. So if you substitute here, so you can substitute this y equal to 2 and x equal to 1. So then we have this one. So simplify it, you will have your c equal to 1. Once you obtain the value of c, then substitute back the value of c into the equation 1. And then you will have this answer, and this is actually your particular solution for this example 2. Okay, let's just look at example 3. So in example 3, okay, what you have here is you have a y prime. So change this y prime to dy dx. Okay, so in this differential equations, you can see that you have dy dx and you have one variable y. So compare this one with the general form of the linear equations. So you have dy dx and one variable y. So you have the form that is look like the general form of the linear equations. Now, the next thing that is you need to identify what is your px. Your px is the one that is next to the variable y. So this is your px. This is next to the variable y. Your px is actually cotangent x. And then what is your qx? Your qx is the one that is at the right hand side of the equations. So your qx is equal to e to the power of cos x. So the next thing that we need to do is we need to find the integrating factor by using the formula. So this is the formula of the integrating factor. So it's equal to e to the power of px dx. So your px here is the cotangent x. So substitute here. So you will have this one. Okay, integrate the cotangent x. It will give you the ln sine x. So you have the next line. You have e to the power of ln sine x. Okay, according to the concept that we have learned just now, basically, this is actually equal to the sine x only because you can cancel the e and the ln together. You have sine x only. So this is your IF. So once we have identified our IF, then we have to solve this differential equation by using the formula. So this is the formula. Okay, so it says that you have to multiply the y with the IF. Okay, so y multiply with the IF, that is your sine x. Okay, and then it's equal to the integration qx. Your qx is e to the power of cos x, and multiply with if dx. Your if is sine x with the dx. Okay, so we're going to solve the right hand side of these equations. So we're going to do the integration. So this integration, you can solve it by using the technique of substitution. Just substitute this one with a u. So substitute this one with a u, and this one you differentiate it, you will have du equal to minus sine x dx. Observe that we have sine x dx here, and we also have sine x dx here, but we do not have the negative in here. So what you have to do is you have to bring the negative to the left hand side. So you will have negative du equal to sine x dx. Now let's just do the substitution. So if you substitute, okay, this is e u, and sine x dx is basically give you this one that is equal to negative du. And simplify it. Okay, so if you simplify it, that is what we get. Okay, then integrate EU will give you EU. So then we have a plus C. Okay, the U here, you have to change it back to this one. Okay, because it's supposed to be in terms of X only. So you change back to the cos X. Okay, so then you have the next line. Do not leave your answer in this way because your answer is supposed to be only have Y at the left hand side. So divide all of them with the sine X. So this is what we have. Okay, so this is the general solution for this example. So you can leave your answer in this way. Some people will improve this solution because the 1 over sine is actually equal to cosecant x. So it means that you actually can modify this solution into this way. So you will have cosecant x as the answer. So this is actually another version of the general solution for this example.